All right, so this video should be a replacement for Tuesday's class in which we're going to talk about the next topic, which is not, we've already talked about perfectly competitive markets, monopoly markets now. The next thing we're going to talk about are oligopoly markets, right? So oligopoly just means a few number of firms. So these are going to be models in which we only have initially just two firms. You can think about if we have three or four, how would that complicate things? For the most part, when we look at these oligopoly models, we're just going to focus on two firm models. The math just gets harder with more firms, but the same principles will apply. So we're also going to introduce this concept of game theory in this chapter, which is something that is used in economics. If you think about it, kind of got the movie here. If you haven't seen A Beautiful Mind, it's an old or a young Russell Crowe, but it's a great movie. It's about an economist that really popularized game theory, started applying it to a lot of our different economic principles and problems that we have. And kind of the main concept of game theory is that we're going to try to understand decision making by individuals. And we say that there's going to be an equilibrium for decision making, which every party involved so for us, it's going to be some basic two firm or two individual models that each person is best responding to what the other person is doing. Okay. So we'll see kind of how this plays out in a second, but the basic setup is going to be we have two players, right? So we can have more than two, but for all of our examples, we'll kind of stick with, well, for most of the examples that we'll have, or as far as I'll push you, are two individuals, two players. They're going to make decisions. So sometimes this is just two decisions. It can be more than two. So we'll have some models, and I could expect you to look at two-person models where they have more than two decisions. And then their strategies are going to be all these possible choices they can make, right? We're then going to talk about the combination of these two strategies. So person one, for example, could set a high or low price. Person two could set a high or low price. The combination of their choices are going to lead to payoffs, right? Now, in most of these models, we're going to talk about the payoffs is either going to be like the utility that someone gets or the profit that a firm gets, right? So the benefit to each player, these payoffs will be a result of the combination of the strategies they're making, right? Usually, we're going to draw this out in a normal form matrix. So not in this video, but the next one, we'll talk about how decision timing matters, right? So when decisions are made, does person one make the decision first? Do person one and two make the decision simultaneously? So we're going to start off with models where everyone's making their decision at the same time. We're going to depict these models in a normal form, what we call matrix. And then we'll talk about if they aren't making them at the same time, what does that look like? So our general payoff matrix is going to have all of this information. Who are the players? We'll set this example up to be firms one and firm two. What are their strategies? They can set either a high or low price. And then depending on that combination, are they both setting a high price? Are they both setting a low price? Alternate strategies. What are the firm's payoffs going to be? So we've got a couple different ways of depicting this. The first is going to be like this. Right? And I'll show you another example of, we can sometimes write the payoffs a little bit differently. And I kind of like the other way, but we'll start out with this one because it's kind of the more conventional display. So we've got firm one, firm two. If they both set a high price, here's firm one's payoffs. Their payoffs are going to be on kind of the left. Firm two's payoffs are going to be on the right. If firm one sets a high price, firm two sets a low price. Firm one's payoff is on the left. Firm two's payoff is on the right, so on and so forth. Okay? So this is our payoff matrix. Okay? So game theory is going to help us understand, okay, if I have this market with two firms, are they both going to set a high price, right? Are they going to kind of collude, or are they going to both end up kind of folding to market pressure where we see them both set a lower price? And we'll talk about why we end up at our Nash equilibrium. So when we're analyzing these models, we sometimes will have that a firm has what we call a dominant strategy. So regardless of what the other person does, so if firm one sets if firm two sets either a high or low price, if firm one's best response is to always set a high price, we would say they have a dominant strategy, right? So their action doesn't depend on what the other players or the other person's doing, okay? If they both have a dominant strategy, well, if firm one always has a dominant strategy set a low price, firm two always has a dominant strategy set a low price, we know what the Nash equilibrium is going to be. Each person, their best choice doesn't depend on what the other person does. So we know they're both going to choose to set a low price there. Right? For example, if your best response, regardless of whatever I choose to do, if I choose to put out a recording of the class or not, if for you, the best response is always to show up in class regardless, well, then I know the equilibrium will always kind of be that you show up to class. And if it's always best for me not to put out a recording, well, if we both, have this dominant strategy, we know that the Nash equilibrium will be I don't put out a recording and you show up to class. Now, that's not quite the case in our class example. I put out these recordings, but that would be the idea. We'll also talk about a prisoner's dilemma, which is going to be a game in which both of our kind of best responses to what the other person is doing leads to us both being worse off. Or if we could somehow cooperate and make different decisions, we could actually both be better off, right? Or there's going to be another choice of strategies that would make us both have a higher level of profit, utility, whatever we're looking at. So these are just some strategies or terminology that we'll use, okay? And I'll walk through them as we work through the example. So let's say I've got this example where two individuals suspected bank robbers, and here we're not talking about firms yet, but we've got enough evidence that they bring them in for questioning, and neither of them confess. They both get 5 years. So we've got some evidence, but not strong enough. So maybe we get them on some lesser charges, so they both get 5 years in prison. However, if we put both of them in separate rooms where they have to make a decision simultaneously, so all of these initial models, we're assuming people or firms are making decisions at the same time. We say, okay, look, if you confess and rat out your partner, you get to go free. Because now we've got enough evidence to put your partner away for the whole bank robbery. They're going to go away for a much longer time. So if you don't confess, you get 0 years, but your partner is going to get 25. Okay? And let's just say we start out assuming that all I care about is having the least amount of jail time for myself. Maybe I committed this crime with this other person. I have no tie to them. I don't care what happens to them at all, right? So if we both confess, well, there we can't pin it on okay, we can't let you both go free, but we now have enough evidence to kind of put you away for a longer period of time. We're going to give you both 10 years. This is kind of the setup, right? So here we could think about how can I depict this in a normal form game, right? Well, excuse me. If I have that Joe and Dan both confess, we said they would both get, oh, sorry. I want to do this first. I'll go back. They would both get 10 years. Right? If Joe confesses and Dan doesn't, well, Joe gets to go away scot-free. Dan gets 25 years. Right? So here, if Dan confesses, he gets to go free. But if Joe doesn't rat out Dan, he gets 25 years. Okay. So here's kind of our different combinations. If they both confess, they get 10 years. If Joe does not confess or rat on Dan, but Dan rats on Joe, Dan gets to go free, Joe gets 25 years. If the opposite's true, Joe confesses and Dan remains silent, Dan gets to go away for 25 years, Joe goes free. And if they both remain silent, that was the initial case we said they would both only get lesser charges of 5 years. So here's all of our different payoffs, right, of these different combination of strategies that the two players can make. So we'll start to kind of go through how do we solve this normal form game, right? So I'm going to actually draw this out for us because I think it's easier to kind of see me work through this. So let's say I've got Joe, he can confess or not. We also have Dan, he can confess or not, right? So we said, here's our kind of payoffs. They both confess, they get 10 years, 5 years. If Dan confesses, he goes free. Joe gets 25 years. Joe confesses, Dan doesn't, he goes free. Dan goes away for 25 years. Well, in this example, less jail time is a better thing, right? So I'm trying to maximize my utility. I'm going to try to be in jail for the lowest amount of years possible. So how you would solve these models is you first go through and say, okay, look, if Joe decides to confess, right? So Joe is choosing to confess. What is it optimal for Dan to do? Well, if Dan doesn't confess, he gets 25 years. If he also confesses, he gets 10. So what is his best response to what Joe is doing? To also confess. If Joe doesn't confess, what should Dan do? Well, if Dan confesses, he gets 0 years in prison. He doesn't confess, he gets 5. Here we would say, regardless of what Joe chooses to do, Dan has a dominant strategy to confess. Right? Now, we can do the same thing and determine what should Joe do. Well, if Dan chooses to confess, what should Joe choose to do? Well, if he confesses as well, he gets 10 years. If he doesn't, he gets 25. He should also confess. If Dan chooses not to confess, what should Joe do? Well, his payoffs are on the left, remember. If he confesses, he gets 0 years. If he doesn't confess, he gets 5. 0 years in prison is better than 5. We see here that Joe also has a dominant strategy to confess. So if they both have a dominant strategy to confess, what do we know is the equilibrium? They're both going to confess. So anytime you have these like little circles, those are the best response of one of the players to what the other person is doing. Well, if we're both best responding to what the other person's best response is to our action, that was our definition of our Nash equilibrium. So here with two dominant strategies, we know that Nash equilibrium, where we're both best responding to what the other person's doing, will be for us to both confess. And you can kind of think about the thought process behind, well, why isn't this going to be the Nash equilibrium? If we're both choosing not to confess, what could Dan do? He could choose to rat out Joe and confess and actually end up with less jail time. So this can't be an equilibrium. Dan's not optimally or not best responding to what Joe is doing here. Now, if we're here, where we said is the Nash equilibrium, if Dan's confessing, should Joe not confess? Well, no, he'd get more jail time. If Joe's confessing, should Dan choose not to confess? Well, no, he'd get more jail time. We're going to stay at that same combination of strategies or at our Nash equilibrium. Okay. So have this example where, oops, I kind of identified this here. Here's all of our best responses, the point where we're both best responding to each other's best response, or we kind of have these circles in the same box. It's not less technical way of thinking about it, is going to be where they both confess. Okay. So our outcome here, hold on. I updated these numbers. So that should look more like it. There we go. So the optimal, or sorry, we already worked through this. I'm on the wrong slide. There we go. The outcome is going to be that they both confess and get 10 years. Now, they could have been both better off if they remained silent, right? If they both remained silent, they both would have only gotten 5 years, right? So we have here that the Nash equilibrium actually results in a worse payoff for both of them. So this would be kind of our Nash equilibrium that they both confess. But at this Nash equilibrium, the outcome is worse for them. If they could both agree not to squeal or not rat out each other, they'd be better off. This would be the example that we have a prisoner's dilemma. Okay. So this is kind of a less technical version, although we can apply game theory to these types of scenarios, but it might be a little more likely we want to apply it in economics to a market, right? Where we have two firms. So we think about if we had two firms, it's going to be a kind of slightly different model of different choices, different strategies, but also different payoffs. So here I've got two phone companies, right? Kind of simplify it. They're what we call an oligopoly, but a duopoly. There's only two firms. Oligopoly means few. Excuse me. Duo means two. All right, so we're simplifying this down. Let's say we know that if we restrict quantity, right, if we move, to a lower quantity, that consumers are willing to pay a little bit more. So we might have these two companies agree to try to work together and not sell to as many customers. So they, agree to 30 customers, right? You can think about, well, what's the Nash equilibrium going to be? If I'm T-Mobile, well, why might I want to sell to more customers? Well, because it's not going to influence the price that much. The price might decrease as we increase that quantity, right? We're moving to the right there in our graph, but I'm selling to more people, so I could potentially be increasing my profits. So we'll kind of think through, how do we solve these, what we call cartel models, right? So here's our different kind of options. We could say, instead of both producing 30, we could both produce a higher, right, quantity, which is 40. Right? Now we'll end up seeing why the best move is to produce more, but we can kind of work through why with some actual profit values. So let's say I have this normal form game. I've got that Verizon and T-Mobile, and here I just chose some numbers. We could think of this as choosing to set a high or a low quantity, or, this decision is made like at every quantity jump. So 30, 40, 50, 60. We've just simplified it here to just looking at two different quantities to make the models a little bit easier. So Verizon can sell to 30 customers or 40. T-Mobile can sell to 30 or 40. Now we know that if we restrict the quantity, that's going to keep the price higher, that both of us could earn $900 of profits. Now, if we both choose to sell to more customers, it's kind of like we're increasing the supply, but that's going to lower the price. And so we might end up with profits that if we both sell to more customers, we're both only earning 800. So kind of notice here, if we could just choose between these 2 points, both of them would be better off if they restrict quantity. However, there's going to be incentives to be the one firm that doesn't. Okay. So got this in the slides here, but I'm going to show you a slightly different way of depicting this. There we go. And then kind of working through how we would solve this. So let's say I forget who was on what axis now. So let me, oh, sorry about that noise. So I had Verizon over here, had T-Mobile up here, quantity of 30, quantity of 30, quantity of 40, quantity of 40. So I'll sometimes give you those normal form games as like a matrix where we kind of had those diagonals. Another way we could depict these profits are simply by writing firm one's profits first or payoffs first, and then firm two's second, right? So this would be like firm one, firm two. This would be, here's firm one, here's firm two. And then we could kind of work, do the rest of these. So we had what, 750 and 1,000. I'm just copying what's down in the slides here. 800, 800. So let's go through and solve this model the exact same way we did for the kind of jail time one, except for now, higher numbers are better, right? Higher profits are better. So if I'm T-Mobile and Verizon is choosing to only hold true to our agreement and only sell to 30 customers each. Well, if I sell to 30 customers too, I get $900 of profits. But if I say, yeah, I'll sell 30, and then secretly I sell to 10 more customers, well, that is going to push down the price a little bit. So that's going to be a bad thing for Verizon. But yeah, push the price down a little bit for me, but I'm also selling to 10 more people. I might be able to increase my profits. So if Verizon stays true to our agreement, it's actually better for me to be the one that breaks the agreement. Now, what if Verizon breaks the agreement? Well, if I hold true to it, I'm getting $750 of profits. If I also break the agreement and sell to more customers, I'd be better off, right? If I also break the agreement. So we just went through T-Mobile's kind of best responses to what the other person is doing. Notice, what do they have? Well, they're always their best response to regardless of what Verizon does, they have a dominant strategy to always break the agreement. Now, what about Verizon? If T-Mobile holds true to our agreement and they only sell to 30 customers, if I also hold true to the agreement, I get $900 of profits. If I break the agreement behind their back, I can get higher profit levels. What if T-Mobile breaks the agreement? Well, then if I hold true to the agreement, I only get $750 in profits. If I also break the agreement, I would get 800. So where are both individuals? So notice here, regardless of what T-Mobile does, it's always optimal for Verizon to break the agreement. So what's our Nash equilibrium? Where we kind of said we have two best responses in the same block, less technical way of thinking about it, but we're both best responding to what the other person's best response is. Or we have this dominant strategy equilibrium where, look, this is our Nash equilibrium. There is this incentive to always be the one that breaks the agreement. But as a result, what happens? We're worse off than if we both could somehow agree to work together and restrict the quantity. So a lot of the times in these duopoly models, we have a Nash equilibrium that is a prisoner's dilemma. We end up at a point where both individuals are worse off. Excuse me. And that's just a slightly different way of looking at it. Here was kind of the other way where I don't write them left to right. I kind of write them in these like diagonal boxes. We would have the exact same decision, right? T-Mobile has a dominant strategy to break the agreement and sell to 40 customers. Verizon has a dominant strategy to break the agreement, sell to 40 customers, and we end up with this Nash equilibrium where they're both worse off, right? If they could just both agree to not sell to more customers. Okay. So this is the kind of general idea of this duopoly model. So we'll see it a little bit more complex here. So let's kind of make some simplifying assumptions for this model. I think I said marginal cost is constant. So just kind of to make it the math a little bit easier here to think about. So if I've got a constant marginal cost of 50, if I wanted to know where's the perfectly competitive long run equilibrium price, right? Well, we know that in the long run, if this was a perfectly competitive market, these two firms would be choosing where marginal cost is equal to marginal revenue. Now, this marginal revenue is based off of the entire demand curve. So this quantity of 6,000, we know that in the long run, right, we're going to see the market arrive at this quantity where, where marginal revenue is equal to marginal cost. But this marginal revenue would reflect, like, notice it's twice as steep as demand. So this was like if it was a monopolist. So here, if we're just thinking about just the regular demand curve, well, that's just the different combinations of price and quantity. We would get that, okay, my marginal cost is equal to the marginal revenue. For a perfectly competitive firm, the marginal revenue is simply the price. So marginal revenue, perfectly competitive firm, is equal to the marginal cost at a quantity of 11,000. But if we're thinking about, if we're thinking about if we have a duopoly model, though, how much would each firm have to be producing? Well, if it's a total of 1,100, each one would be producing 5,500, right? So what if this was a monopolist, right? Well, now the monopolist, I forgot about the perfectly competitive slide. So here we've got the monopolist. Now this is what we need to be looking at, not the demand curve, but the twice as steep marginal revenue curve. So for a monopolist, what would the price and quantity charged be? Well, marginal revenue, it would be equal to marginal cost of 50 at a lower quantity. That was one thing we said that's true about a monopolist. We worked that last week. So there, the total quantity in the market would be 6,000. And we would go up to the demand curve to figure out the price. So then notice here with a monopolist, the price is higher, quantity is lower than the perfectly competitive market. Okay. So this is just a table form of what we were doing with the graphs, right? Identifying where the perfectly competitive firm would operate. Well, where that point of the demand curve, where marginal cost, or our supply curve, I kind of kept it constant to make it easier here, hits our demand curve. So that's going to be at a higher quantity, a lower price than if we were to make decisions like a monopolist based off of this marginal revenue curve that's twice as steep as demand. Okay. So that's kind of some things we've already talked about. Now, if I had a duopoly, I kind of mentioned this already, if they're both agreeing to act like a monopolist, well, here we would say, okay, together, what would be if we acted like a monopolist, like we worked together and made our quantity decisions, we should be setting the quantity at what? 6,000, right? That's where monopoly profit maximizing quantity was for the monopolist. Well, if there's two firms, that means each of us should be producing not 6,000, but 3,000. So we would still identify where would the monopoly profits be, just the same way we would before, but now each firm is only going to be producing half of that because we have two firms. So they're both set a higher price and they're both going to be selling 3,000 units. They would then split monopoly profits. Well, why is that? Oh, sorry. Why is that better than if we acted like a perfectly competitive firm? Well, what do we know profits are in the long run for a perfectly competitive market or perfectly competitive firms? 0. So at least now here, if we can act like a monopolist, yeah, we don't have monopoly profits. Our profits would be monopoly profits divided by 2, but that's still better than 0. When firms are acting together like monopolists, they set the marginal cost equal to marginal revenue. They can charge this higher price. Now, this would be the total quantity in the market. They're each going to produce half of that. So why might that break down and we end up back at the point of the perfectly competitive market? Right? So we kind of left off here. I had this slide blank because I wanted to work through why collusion can break down, right? So let's say I've got two firms, so firm one, and they can set this low price, kind of agree to the collusion agreement. They can also set low price, low quantity or a high quantity. Firm two has that exact same decision, right? So we're going to have this payoff matrix with the different combinations of strategies. So if they both work like produce a lower quantity like a monopolist would, we're going to enjoy maybe both earning a pretty high level of profits. Now, if I'm the firm that breaks the agreement, because there's a higher quantity in the market now, that's going to push the price down. So for the firm that is still producing 30 units, they're not going to be selling at a lower price, right? We could end up with saying they're going to see quite a bit of losses, right? Now, the firm that is producing a higher quantity, yes, the price effect will decrease their profits, but because they're the one producing more, that quantity effect or output effect is going to take over. Well, we said if we're operating on the monopoly, like a monopolist, we'll be on that elastic portion of the demand curve. It should be, right, that we actually see here, profits are going to be a little bit higher for that firm that broke the agreement. And then kind of the reverse would be true. If firm one is the one that breaks the agreement, the price will now go lower because there's a higher quantity on the market. But if firm two doesn't break the agreement, well, the price is now lower. They're still selling the same number of units. They're going to see a loss of profits as well. Right? Now, if we both produce more, that is going to push the price down, right? We're moving down the demand curve, but we're now both selling a higher number of units. So maybe we're still earning positive profits, but they're just not as high as if we could agree to work like a monopolist. So we'll go through, solve for what each firm's best decision is, right? So if firm two is choosing to hold true to this agreement and set the lower quantity, what should firm one do? Well, if they hold true to the agreement, they get 60. If they tell the other firm they're going to hold true, but then they break the agreement and produce a little bit more, supply a little bit more to the market, they can actually earn higher profits. If firm two breaks the agreement, but firm one doesn't, they're only going to get 30 million. If they also break the agreement, they're going to get 50. Same kind of thing on the flip side, since I kind of have these symmetric payoffs. If firm one holds true to the agreement, what should firm two do? Well, 70 is greater than 60. If firm one breaks the agreement, what should firm two do? 50 is greater than 30. This is going to be an example where we say, oh, where's the equilibrium? It's going to be down here where both firms break the agreement. And then you could kind of continue to build this out, quantity of 50, and it's basically the same incentives will exist, and it pushes us down to that perfectly competitive outcome where we get profits are equal to zero, right? So the prisoner's dilemma can kind of help explain why in certain markets, if the cost structure is in such a way where these incentives would exist, we can actually get that firms won't act like a monopolist. They'd be better off if they did, right? Both would be earning 60 million instead of 50, but there's always the incentive to be the one firm that breaks the agreement, right? And because there's that incentive, notice both of them have a dominant strategy. Firm one will always choose to set this higher quantity. Firm two will always choose to set a higher quantity. So we know that both of them will set this higher quantity, pushing us towards that perfectly competitive equilibrium. Okay. So we've got a couple other examples. I'll leave this here for a second. So I've got a couple other examples here. And there we go. Switch over to my screen. So I've got these problems in, going too fast here. So, well, you'll kind of see them up here. I'll just rewrite them. I think it'll be easier for me to do these kind of on the dot cam. So I'm going to stop this share here and just rewrite this out. Okay. So what are some other examples that we could see this prisoner's dilemma, or how would we solve for equilibrium? So let's say, excuse me, I've got United and they can cut fares or they don't cut fares. Same kind of thing. I've got, what's the other airline? I chose American Airlines. They can cut fares or they can not cut fares. It's going to be kind of a similar example to what we just worked through, right? But if they both cut fares, they're earning 400 million. If they both don't cut fares, I've got them at 600 million. If I'm the firm that cuts my fares and the other doesn't, well, everybody wants to fly on my airline. So I'm going to get even more of the consumers. The other company will get fewer. Same kind of, oops, we're at the million here. Same kind of payoffs that exist here. So I'm keeping payoff symmetrics for right now. Next video, we'll kind of change this so it won't be. But now I can go through and solve this model, right? So what should American do if United chooses to cut fares? Well, if they cut fares, they get 400 million. If they don't, they get 200. So there's their best response. What if United instead doesn't cut their fares? Well, then what should American do? Well, they should be the one that cuts their fares. Everyone's going to want to fly with them. They can make more money than if they also didn't cut their fares. Now we make the decision, and here I can change this color for United. If American cuts fares, what should United do? 400 is greater than 200. If American doesn't cut their fares, what should United do? 800 is greater than 600. Now notice what combination of strategies is where both individuals are best responding to each other. It's going to be where they both cut fares, moves us away from a point. If they could somehow agree, hey, I'm not going to cut my fares as long as you don't cut your fares either. Well, then they could be both better off. But when we're in this scenario, there's always an incentive that pulls those firms to break that agreement. Right? So here we have just another example of the prisoner's dilemma. Okay. Now we'll look at a kind of slightly different model, right? So sometimes our equilibriums can be a little bit different. Right? So let's say I've got person one, and they can either work hard or what we call in the labor economics, shirk, right? Basically, kind of slack off, right? So not work hard, right? So this is kind of a labor economics model that's pretty popular or pretty common. So here, if both these workers are working hard, well, maybe the payoffs aren't symmetric, right? And maybe it's not in terms of profits. Now we've got individual decision-making. Maybe this is like their utility. Right? Now, here, I think I have in the problem on top hat, I'll just fill out the rest of the payoffs and make sure I'm getting these right. Okay. So we would go through and solve these the exact same way. We would say, what is person one's best response to all of player two's or person two's choices? Well, if person two is working hard and person one is working hard, their utility they get is 10. If they slack off, they get 6. So they're going to choose to work hard. Now, if person two is slacking off, right, or shirking, what is person one? Well, person one must have some kind of like real, they must get a lot of utility from working hard. And so they're not going to want to slack off. Now, for person two, maybe working hard is a little bit more costly to them. So when both of these workers are working hard, the payoffs are high here. But if I slack off and the other person works hard, well, my boss doesn't really know who's doing what. We're working at the same time, but I really have this huge cost when I work hard. I really don't like to. So notice the payoff now is a little bit higher for person two to kind of slack off. And then down here, well, if the other person's slacking off and I slack off as well, maybe I could put zeros here where they lose their job, but now the boss is mad at both of us. Maybe we'll cut our wages. So if the other person is not working hard, person two should choose to work hard, right? It's a little bit better of a payoff. So where's my equilibrium here? Excuse me. It's going to be where person one works hard. They were the individual had a lower cost to working, right? And then person two is going to choose to shirk or not work hard. So here we've got this equilibrium where person one works hard, person two slacks off or shirks. So we don't always have the same strategy choices. A lot of these examples I was showing you before were prisoner's dilemma, which was where both individuals had the same strategy choice, right? In the equilibrium point. We can have equilibriums where that's not the case, right? So that would be an example here, okay? So here we've only got one kind of square, less technical way to remember it, where we have two circles, right? Where we're both best responding to what the other person is doing, okay? And then I kind of have another model. It's basically the one that I did at the beginning, but just to kind of give you, if you're watching, to make sure you're watching these videos, I worked through these top hat questions that I'm still going to be assigning next week. So let's say, get a marker that works. So we had firm one, they can set a high price or low price. Firm two can set a high price or a low price. And then from these different combinations of strategies, I presented to you some payoffs. So we had 10 million, 10 million. We have 5, 15. We have 15 and 5. And we have 7 and 7. So this one, I'm not asking you in the top hat question to identify the equilibrium. I'm giving you a bunch of different choices about which of the following are going to be true. So in order to answer that question, we need to solve this model. So for firm one, what should they choose to do if firm two sets a high price? 15 is greater than 10. If firm two sets a low price, what should they choose to do? 7 is greater than 5. I think I have symmetric payoffs here, so it should be that firm two makes the exact same decisions. When firm one is setting a high price, what should firm two do? 15 is greater than 10. Firm one sets a low price, they should choose to do this, right? So here we have an example of a prisoner's dilemma. Why? Because there's no other combination of strategies where because there is a combination of strategies where both of them would be better off. You can kind of think about in this scenario, from this equilibrium point, there would, even if I move here, one of the people are worse off. If I move here, they're both worse off. If I move here. So there's no other place I could move from the equilibrium where both individuals would be better off. Here, that's not the case. So this is going to be an example of the prisoner's dilemma. Now, they also both have a dominant strategy. Notice their strategy choice is the same regardless of what the other person does. So a non-technical way of remembering this, anytime you have kind of two of these best responses or two circles on the same row, firm one has, or person one, player one has a dominant strategy. Anytime you have two circles in the same column, person two or firm two here would have a dominant strategy, okay? So both firms are going to have a dominant strategy here to set a low price, results in a prisoner's dilemma. It doesn't maximize profits for the total for both firms. So that's going to be one that's not true, right? And then firm one and two will not cooperate to set a high price. Well, that's going to be the one that kind of ends up being true as well. So the only one that is not true was going to be that they're maximizing their total profits, okay? All right, so those are the questions that kind of go with that material. I'll post the next kind of replacement video here where we continue to go through some prisoner's dilemma stuff, but then also introduce some new ideas.